This is Euclid Book 6, proposition number 19, and let me tell you something, this one was one thunder of a bear. So, before we even begin, I'd like to tell you that this line here is called BC. You see BC right here? I made this line 4 inches long. You see this line right here? This one's called EF. See the one right here? It's been made 2 inches long. I went ahead and made AB over here also 2 inches long. And I made DE here 1 inch long. And I also made BG here. See this BG right here? This is 1 inch long. Okay. And then we connected G to A. Alright. Now then, let's get to the heart of the proof. It says similar triangles are to one another in the duplicate ratio of their corresponding sides. Let A, B, C, and D, E, F. Okay, we have triangles A, B, C. A, B, C. We have triangles D, E, F. Okay. Okay. Let A, B, C, and D, E, F be similar triangles having the angle B equal to the angle at E. Well, the angle here at B, as you can see right here, is going to be equal to the angle at E, right here. Okay. And such that as AB is to BC, as this is to this, so is DE to EF. This is to this. As this is to this, so this is to that. So far, so good. So that BC corresponds to EF. Okay. And this is by Euclid Book 5, Euclid Book 5, definition number 11. I say that the triangle ABC, this one right here, ABC, okay, has to the triangle DEF, this one right here, DEF, a ratio duplicate of that which BC has to EF. So, hang on just a second, folks. This triangle has to this triangle a duplicate ratio of this triangle to this triangle. Alright, let's prove it. For let a third proportional BG be taken of BC. Well, we've drawn BG, and it's got to be proportional to BC. Okay, for let a third proportional BG be taken to BC's EF, so that as BC is to EF, well, as BC here is to EF, I draw it, BC, EF, very good. So is EF to BG. EF, BG. So as this is to this, so is this here is to that. Basically, as 4 is to 2, so as 2 is to 1. So far, so good. And this is by Euclid Book 6, proposition number 11. And we're going to let AG be joined. We've already joined it. Since then, as AB is to BC, so as DE is to EF. As this is to this, so as this is to that. So far, so good. Therefore, alternately, as AB is to DE, so as BC to EF. Well, as this is to this, and this is as 2 is to 1, then BC to EF, well, as 2 is to 1, as 4 is to 2. Okay? as 2 is to 1, so as 4 is to 2. Okay. And this is by Euclid Book 5, proposition number 16. Hang on. But as BC is to EF, well, BC and EF, as this is to this, so as EF to BG. Okay? EF to BG. Therefore, also, as AB is to DE, as AB is to DE, so is EF to BG. EF to BG. And this is by Euclid Book 5, proposition number 11. Therefore, in the triangles ABG and DEF, okay, well, this is ABG here, and this is DEF here. The sides about the equal angles are reciprocally proportional. But those triangles which have one angle equal to one angle, in which the sides about the equal angles are reciprocally proportional, are equal. And this is by Euclid Book 6, proposition number 15. Therefore, the triangle ABG is equal to the triangle DEF. This triangle here has the same area as this triangle here. Now, I know you're not going to believe that, but if you will do 1/2 the base to the height, which we actually drew a line here, and we calculated 1/2 the base to the height on this one, and we calculated it to this one, and that came out to be 2 times 0.75 divided by 2, which came out to be 0.75. The area of this, believe it or not, this triangle right here is the same as this. I know that's kind of hard to believe, but it's true. I couldn't believe when I did it myself. Now, since as BC is to EF, well, again we have BC, EF, this one right here, that's this to this, so as EF to BG. EF, BG. And if 3 straight lines be proportional, the first has to the third a ratio duplicate of which it has to the second. This is Euclid Book 5, definition number 9. Therefore, BC has to BG. BC has to BG. A ratio duplicate of that which CB has to EF. BC to EF. So, the ratio of BC to BG, which is 4 is to 1, is a duplicate of the ratio of BC to EF, which is 4 is to 2. Well, if you have a ratio of 4 is to 2 and you take it times 2, you'll have a ratio of 4 is to 1. It's that simple. Alright. But as CB is to BG, CB is to BG, so is the triangle ABC to the triangle ABG. The triangle ABC, ABG. So the big triangle is to the little triangle. Okay? And that's by Euclid Book 6, proposition number 1. Therefore, the triangle ABC has to the triangle ABG. Triangle ABC has the triangle ABG. A ratio duplicate of that which BC has to EF. BC, EF. So in other words, if you were to find the ratio of BC to EF, multiply it by 2, you'd have the ratio of this great big triangle to this little one. But the triangle ABG is equal to the triangle DEF. ABG is equal to DEF. Therefore, the triangle ABC also has to the triangle DEF a ratio duplicate to that which BC has to EF. So the ratio of this great big one to this one is twice what this line is to this line. And then it has a porism. From this it is manifest that if three straight lines be proportional, then as the first is to the third, so the figure described on the first to that which is similar, and similarly described on the second. Don't ask me about that, I don't know. But anyway, that was Euclid Book 6, proposition number 19. I hope you enjoyed it. I will get to the next proof just as soon as I can. Stay tuned.